So in let's figure out the oxidation numbers for this. Let's figure out the oxidation number for this compound. So we know that hydrogen in this case is there's two hydrogens. Hydrogen, it's in its elemental form. So hydrogen here, it's not hogging anything with each other, since there's both of them is have the same tendency or electronegativity. They're going to be in equilibrium, so they're going to have a zero ionic charge. And in oxygen too, you have two oxygen atoms connected to each other. They have the same electronegativity, so they're not going to hog any electrons within each other, so they're going to have a zero form of charge or oxidation number. And then in this case, you have H2O. Hydrogen too would have a +1 charge oxidation state, and oxidation state for hydrogen, and oxygen would have a -2 oxidation state. Okay, so it becomes neutral. It's neutral. So in this case, what is the oxidation agent in this case? So the oxidation agent is anything. So in this case, hydrogen is being oxidized since it's gaining a +1 charge, and I mean hydrogen is being oxidized since it's gaining a +1 charge, and hydrogen is being oxidized. Hydrogen is being oxidized since it's gaining a +1 charge, and oxygen is being reduced since it's gaining a -1 charge. So since hydrogen is being oxidized, is obviously the reducer, is the reducing agent. Is the reducing agent because why? It's losing an electron, so it's the reducing agent. And oxygen is the oxidizing agent because it's gaining an electron. So it's what's causing the hydrogen to be oxidized, since it takes that electron from hydrogen. So this is the oxidizing agent. Oxidizing agent. Okay. So this is essential for redox reaction. Now let's learn how to balance a redox reaction. Okay, so let's try balancing this redox reaction. So you assume everything is aqueous, of course, except for the I2 solid, which is mentioned. So in order to solve this type of problem, you need to write the half reaction of each, and balance it without the oxygens, and then add water to it. So it sounds a little complicated, but I'm going to show you step by step. So let's write the half reaction first of chromate oxide, or whatever, chromate. So let's write the half reaction of that. And so let's just balance this half reaction, chromate, this half reaction. So Cr2O7 2- turns into Cr3+. This is just the half reaction of it, right? Okay, so since we have two chromates here and one chromate here, you just write 2 here and it's done, right? Now let's write the half reaction of iodide. So in this case, we have one iodide on the left side. So right now, after writing the half reaction of each reaction, you could basically balance the elements, just the elements, not the actual charge itself. So basically, there's two chromates here. You balance out everything except for the oxygen and the hydrogens, which come later. So you could balance out chromate by itself. So you know that chromate, there's two chromates on the left side and only one chromate on the right. So you could just write a coefficient of 2 here, right? And you know that there's one iodide on the left and two iodides on the left. So you could write 2 here for the iodide, right? But there's a problem here with chromate 207, 2 minus, right? Because you have oxygen here on the left side of the equation, but you don't have oxygen on the right side. Well, what is this? This solution is an aqueous solution. It's in water. So basically you could balance this equation with water. If you add water on the right side of the equation, because there's oxygen on the left side but there's no oxygen on the right side, right? You could add oxygen on the right side by adding water here to it, right? Makes sense? And since there's 7 oxygens on the left side, you would need 7 H2Os, right? To get 7 oxygens here. And since there's no hydrogen on the left side, you would obviously need some hydrogen plus atoms to complement for the hydrogen in this equation, right? So you would need 14 hydrogens, since there's 14 hydrogens on the right side of the equation because of the H2O. You would need 14 hydrogen plus atoms, right? You would need 14 hydrogen plus atoms. Makes sense. So now what do? Everything is technically balanced. Every single element is balanced, but not the charge. For example, here there's the water molecule is obviously neutral, and the chromium atom is not neutral. It has a +3 charge, and there's 2 of them, so it has a total charge of +6. Has a total charge of +6 here on the right side of the equation, and here you have a total charge of 12 because there's 14 hydrogen plus atoms, which is just, you could consider protons, minus this 2 from the chromate, which gives you a total charge of +12. So you have a total charge of +12 on the left side and +6 on the right side. So what do you do to balance out the equation? You could technically add 6 electrons here, and which has a negative charge, and it would balance out, and so each side of the equation would have essentially 6 a total charge of 6. So what about for this equation right here? You have a total charge of -2 on the left side and a total charge of 0 on the right side. So how many electrons would you need to add, and which side would you add it to? Would you add 2 electrons on the left? No, obviously not, because you would have a -4 charge and a 0 charge on the right side. So you would add 2 electrons onto the right side to balance it. Now after this, you could essentially multiply by 3 on both sides of the equation. Why would you multiply by 3 here? You would multiply by 3 here because there's 6 electrons on this equation, right? And you essentially want to cancel this electron with this electron on the right side of the equation. So basically this whole equation, the whole redox equation is this whole thing plus this on the left side, and on the right side is this whole thing plus this whole thing, right? So this is the total equation, right? Because we wrote the half equations. Now if you combine the half equation, you get a whole equation. Makes sense. So essentially if you multiply by 3 here for this half equation, you'll get 6 electrons on the whole equation on the right side, and you already have 6 electrons on the left side, so theoretically you want the 2 electrons to cancel, right? So after multiplying by 3, you would get 6i minus turns into 3i2 plus 6 electrons. So our goal is to cancel the 6 electrons on the different sides of the equation. So if you combine the half equations now into a whole equation, so if you combine this equation right here, this equation right here with this whole equation here, you would get this whole equation right here, right? You will get this whole equation right here, and you could notice that the 6 electrons on the left side and the right side could essentially cancel, right? So right now you have a balanced equation. This is what we were looking for. Theoretically, everything here is balanced in its for every single element and for the charge. Now this is for this acidic solution, right? So if we had a basic solution, this hydrogen plus atom, you would add 14 hydroxide on the left side to neutralize this to get 14 H2O, right? And you would add 14 hydroxide on the right side of the equation as well for a basic solution. So this is how you work redox reactions and how to balance them. Thank you. This is Fall Academy signing out.